This video will explain how the AVO analysis works in OMNi. As with all analyses, once we have a survey and a script, we right-click on the script and go to Create New Analysis. In this analysis list, you choose AVO, Amplitudes and Angles, which is part of the workshop. Click OK and we get this wizard which asks for creation parameters. What we're going to do is we're going to load a p-wave velocity file, which we will use internally to create a 2D ray trace model. So there's our p-wave velocities. Click Next. Now we load our s-wave velocities. Click Next. So what has happened is at every inflection within the p velocity model, we've created a horizon. So we have a constant velocity between these inflection angles, so we've created a 2D model out of this. What we want to do is choose a reflecting horizon that we're going to use for our ray tracing. We'll choose that horizon there. We want to ensure that we're using all of our amplitude losses, transmission, reflection, and absorption, and we're going to apply a 30% stretch mute, which means any trace which is stretched more than 30% will be left out. And then the rest of the parameters are the same as they are in any analysis. I've already pre-computed this, so I'll just turn that on. So let me just briefly explain what we've done. Internally, we created a 2D ray model. I've done that manually as well, so we can see what's going on. So here is the type of model which has been created. Since we created it out of p-wave velocities, what we've done is build a horizon at every p-wave inflection point, and then we've assigned shear wave velocities to those horizons from our shear wave velocity function. If I were to ray trace this model just at 0, 0, and only reflecting off that same horizon that we calculated in the analysis, then what would happen would be I would get something like this. So I have an event along here, and every point on this event is represented by the rays which are highlighted above. So part of those ray parameters include the takeoff angle, which is where it left the shot, the reflection angle, the incident angle on the reflecting horizon, and then the amplitude and time as well. If we were to save that as a seg-y file and apply NMO to that file, then we would get something which looks like this. So what that did was it created that event as a seg-y file using the amplitudes from the Zopritz ray tracing. We then NMO corrected that to bring it back, and this is where a 30% stretch muted it out. Now we can take these events from that ray trace and we can bin them, because every trace in our survey, every trace has a particular offset. Since we have a perfectly flat model, we can use the ray tracing from that model to calculate the trace in that bin, and we can bin it wherever it falls in our ray tracing. So what we've done is in every single one of these bins, we've gathered up all of the traces with the correct offsets, and we've saved all of their statistics in here, and they're all contained in this AVO analysis database. So if I bring up that style dialog, we can look at some of the things we can do with that. Right now we're looking at just the fold, which is the number of traces in each bin which were within the mute range. We could also look at something such as trace offset. So we're going to look at offset, but we need to color it. So what offset parameter do we want to look at? We can look at the span of the offsets. That's the maximum offset minus the minimum offset. Or we could look at things like the minimum offset, the maximum, the average, variance, standard deviation, etc. So if we wanted to look at, say, the minimum offset in every bin, then we get a typical near offset display. But we could also look at, say, the minimum amplitude in every bin and get that sort of display. Or we could look at the minimum incident angle in every bin. Or we could look at, say, the span of amplitudes and that sort of display. All of these statistics are calculated from the ray trace curves, which were created from the ray trace modeling. We can also look at those ray trace curves in the chart view. So if we just drag the analysis over, we can look at the AVO curve cross plot. And what we're looking at here is amplitude versus offset. We can also open up the style dialog and look at other parameters such as say incident angle versus offset, or we could look at takeoff angle versus offset, etc. So those are some of the displays you can make from this information. Since this is a database, we can also go in and limit by offset and azimuth. So in AVO analysis, we typically look at, say, small azimuth ranges, maybe select by offset as well. And if we do that, we can see what our amplitude range is in each bin within those range, or we could select by offset as well. So let's go, say, 1000 and see what's happening in there. So as you can see, by playing with the style dialog and applying certain selections to the data, we can glean a lot of information from this analysis. And that's about it.